Okay, well, maybe moving on to a slightly different topic from what our previous speakers have been talking about. I thought I would present some slides on the supply chain. So understandably, and I think we've got a good idea why, technology developers at this stage generally have to designate all their resources in terms of understanding what and delivering and demonstrating and operating single machines. However, of course, this is all in the quest to get to the arrays, and the building of arrays will present different challenges at volume and scale. And it was something that at Pelamis we were very keen to leverage and use our fairly unique experience in the fact that we've built and operated 6 full-scale Pelamis machines to date, including in arrays and over long periods of time as well, and use that experience and data and learning that we've accumulated over that time and apply that to a scenario of what it might look like at volume. So maybe though, just to run through the context here, of course, and some of the previous speakers have touched on this, wave energy is of course a massive global resource. As Simon said, it's at least one, potentially more than one order of magnitude larger than tide, similarly as a market as well. And I'm sure you're all familiar with maps like this that denote the resource distribution around the globe. Estimations are that with various different economic, technical, environmental constraints, we could see up to 2,000 terawatts, if not more than 2,000 terawatt hours per year towards global energy. And to help you put that into picture, the current global contribution by wind is at around about 500 terawatt hours. So we're talking about something that's potentially more than 4 times the scale of the current global wind industry. So a really big industrial opportunity, given that the wind sector sees about $100 billion of new capex a year. So, and of course, as has been touched on, we're at an early stage here, and we're demonstrating the machines and the technologies that are hopefully the solutions to accessing these resources. And we have a responsibility on us to drive those costs down, and I'm sure you're all familiar with cost reduction curves, of which we've seen a couple of slides. And these are cost of energy reductions that are through learning by doing, volume manufacturing, component optimization, et cetera, et cetera. And of course, Simon touched on the very exciting work that we're doing between Pelamis and ETI, which is looking at the very good experience and data and learning that we've had to date, especially with the P2 machines at EMEC, and the types of enhancements and the cost reduction opportunities that we have to the technology, and deciding which are the right ones to implement on the next phase. We're calling it Enhanced P2, that we envisage would be a first commercial machine that we would take to market. And we'd see that deliver a cost of energy step reduction. But of course, the larger picture is that the cost reductions we would anticipate would continue to be seen as we grow in volume and time. And we certainly think that there's a very compelling case, given where we are now in terms of costs and costs of energy, as to why this does need continued investment and continued support, because if you apply even some very conservative cost reduction factors, you get to very exciting places that are certainly competitive with offshore wind, and that's within reasonably small capacities. But behind this all, this is of course actually a supply chain journey, and it's a supply chain journey of not just about Pelamis, but of a lot of businesses behind us that support us in what we do. And so this is a journey that we have to travel with that supply chain. So the near-term context of commercialization and seeing an industry land is we see around what the projects that are being developed, especially in Scotland at the moment. And there's a number of which we have either been identified as a technology supplier, or we're in joint venture under development, or we're in fact developing project sites ourselves. And we see these project sites in Scotland where we have got very, very supportive policy and regulation backed up by UK and Westminster to put in place the right financial mechanisms. You've heard Charlie talking about some of the capital funds that are there to support the delivery of these early stages things. And of course, both the Scottish and the UK government have been very proactive in creating markets, and we hope and proceed under faith that CFD will do the same. But we see this as the opportunity for the industry to build out and really land its roots here in Scotland. And of course, the big story behind this from a supply chain point of view and a political point of view is not just the low carbon electricity, it's the fact that potentially there's hundreds of £billions worth of export market here that, provided we land the industry here, we can take a percentage of that. So we decided to try and put a bit more meat on the bones about what some of the supply opportunities might look like and what the supply chain might look like and some of the areas that may be constraints. It's a bit of a sense check for us as a business that we potentially are overlooking real risks within the technology design or the way that we deliver it, that if we don't resolve them now, may become real blockers to our business. So we're very keen to have a look and a sense check of the way we manufacture, the way we deliver the machines, and how we might do that at volume to ensure that we're not locking ourselves into major constraints down the line. And we drew on the massive amounts of data and experience that we've got in-house, but we also went externally as well, spoke to suppliers that we work with, spoke to vessel operators, et cetera, et cetera. And we really focused the work into three main areas: the machine supply, site construction, and operation and maintenance. And we started with looking at the current way that we do it and our current facility. And we're very fortunate to have actually secured a facility, a substantial facility in Leith Docks, which has 13,000 square meters of covered roof space. And we have our offices adjacent to that. And we managed to secure this facility. It was a redundant hand-me-down by a transformer manufacturer. And we were very fortunate to be able to move in. And this, in fact, we did the full build, fabrication, and assembly of the Scottish Power and the E.ON machines within these sheds. And that was a really vital step for us at this early stage, to have the engineering right on top of where machine build is happening. It allows us to understand, control quality, control risk within the build process. And it's also an excellent facility. We have access to the Forth Ports, which is a tidal lock base, and various other things. And the flow diagram on the left there kind of shows the general steps that we see through the build of Polaris machines. And perhaps just to expand, us as a company, we really, I guess, we pull together the components from the supply chain, and that includes the large structural elements. So we subcontract steel fabrication out and things. And on previous builds, we've had the subcontractor come on site to do that. And our technicians and engineers assemble them, commission them, test them, put them into the machines, and then we do the launching, connection of the machines, commissioning, installation, and maintenance. And one of the other things that we're very keen to include here as well, and it's something that we're looking at with the work that we're doing with ETI, is actually using potentially other materials. At the moment, we use steel for marine structural elements. We're also looking at things like concrete. There's a number of not just cost benefits potentially of moving to concrete, but a number of other technical reasons. So we wanted to include that type of scenario in a supply chain view. And we set it around a near-term, believable context. You know, I've just talked about billions of pounds worth, but it's not really worthwhile trying to map what we're doing now onto hundreds of machines a year. Let's look at the near term, where we have far more certainty and applicable experience to develop the scenario. So we looked at a 10 megawatt a machine, a 10 megawatt per year construction volume. And that, with a P2E, which will be a megawatt machine, would be about 10 machines a year. And in fact, the facility that we have at the moment, we didn't see any major constraints associated with it. And we built up very detailed floor layouts, space area, tooling, all these sorts of things, gathered from previous builds, and applied it to the facilities that we have. And at relatively modest costs of £3 to £5 million, we believe that we can get the facility that we have at Leith in Bath Road up to 10 megawatts a year. And I guess some of the variants on that are bits of infrastructure that you may not decide to invest in on the back of just 10 machines, but they may need multiple. So things like slipways, it might not be cost economic just for 10 machines, but if you're actually going to do 2 or 3 years worth, then yes, it's more cost effective than bringing in heavy lift cranes. So it's a bit of a positive result for us on that, in that we didn't see any major constraints or huge bottlenecks or injections of cash to take our business to the first modest stage of volume production. The other thing we actually looked at was some of the material supply as well. So, and it's something that often people kind of go, oh, how much steel is that and everything. And yeah, it's quite a lot of steel. If it was purely steel machines, we'd be talking about 6,500 tons of sheet, which is road transportable in the sheets that we're talking about. And in fact, if we're talking about concrete, about 9,000 cubic meters, which sounds like a lot, but in fact, even modest batching plants, of which there's one just outside our gates, can produce that type of volume in months. So again, we're not talking about volumes, we're not talking about logistics, which are particularly frightening, especially in the UK context. And in fact, you can see that there's massive amounts of headroom before you would ever get concerned. But nonetheless, there are constraints around Bath Road and our Leith facility, and these pictures here kind of start to contextualize some of the things that we're dealing with. The low loader there, the picture on the back is actually of the P2 at the moment, but the black circle is showing potentially the dimensions of P2. So we are becoming incredibly big structures that are not really road transportable. And of course, we're down in Edinburgh, and most of the projects that we're talking about are around the north and the west of Scotland. So we're talking long transits, long tows, there's risk, there's costs, there's weather delays. So ultimately, we felt that probably at Bath Road, there would be a break point at about 15 megawatts or 15 machines per year. It's not to say that's a hard ceiling. There is further space, there's further facilities, but they would require increasingly larger amounts of investment to make them happen or increase the throughput that we could achieve in Edinburgh. And so we looked at models of how we would counter this. And it's fairly standard sort of hub and spoke, or what might be called hub and spoke. So we'd look to retain probably the high-end PTO assembly. But part of that, and fortunately we've got very forward-thinking, very clever people in the engineering department already working, acknowledging that these are things that we need to be thinking about. So there's a graphic there about how we envisage the next PTO system, which is very close to the PTO system that we have at the moment, being modularized for P2E, and that would be able to fit in a container. So we'd do all these sorts of sub-assemblies, bearings, PTOs at Bath Road in Edinburgh, and be able to dispatch them by road to a spoke facility that would be there for the larger structural elements. And of course, I'm sure most people are aware there are multiple sites that we feel are appropriate around Scotland, and especially in the north of Scotland, that would be able to provide those facilities. And they may not have everything right now, and we've kind of mapped quite clearly what those facilities might look like and the options that are available to us. But what we are aware is, of course, these are facilities that are not only, in many instances, are still heavily used at the moment, but are also being eyed up for use in things like offshore wind. So ultimately, where we might look to site a spoke facility will probably be a decision that will be open to a number of stakeholders to take and will be reflective of current usage down in the years to come when we look to set up. But again, there are facilities out there that are of suitable scale with existing infrastructure that don't present bottlenecks or major gaps. The other thing that we were able to do was have a look at what that supply chain looked like. So interestingly, this pie chart here shows what we believe would be a makeup of a concrete P2E. And if any of you are aware of wind statistic, this is actually the inverse of theirs. I think most offshore wind farms now are about 80% supplied from outside the UK. We believe about 80% could be from within the UK. In fact, the Denmark slice here was sheet steel because we don't have a rolling mill in the country that can produce the sheet that we'd need. So that's not something that we couldn't address and have done in the UK. And we started to build up pictures of full-time equivalent. What I would say is the numbers that we show here don't, apart from the subcontractor, the major structural element, we haven't managed to capture the full-time equivalent of the direct jobs within the supply chain. And I think you only need to walk around the exhibition hall here and you can see the size of the supply chain for the wind industry and gearbox and things like that. Of course, we would anticipate there would be a similar scale, you know, hydraulic cylinder manufacturers, seals, et cetera, et cetera. We haven't been able to capture that data. So either that, and we would consider that be direct, and there would be indirect jobs beyond it. So moving very quickly through this, we also looked at some of the site construction supply side of things, looking at, depending on sites and constraints and geotechnicals and things, you may be forced to use different anchoring solutions. And they then enforce you to go down certain vessel routes and vessel requirements. So we're keen to look at both vessel market availability, rates, and things like that, and how you would use that. Applied that to array architecture that we believe is likely to be used for Pelamis, and look at things like weather statistics. The graph you can see here, the blue, well, sorry, the lines that you show are what we would call the summer construction. It's April through to September. Today is not a good example. And we're talking about, and again, this is weather statistics, you know, if you are able to work in up to 2.5 meter significant wave height, which anchor handlers can for sticking in embedment anchors, you're talking about 90% availability through these weather windows. So again, through this study, we didn't find any particular market constraint. Again, you only need to look offshore the harbor today, and you'll see the myriad of anchor handlers sitting waiting to work. So we don't believe there's any specific vessel shortage in the vessel specifications that we would look to use construction work. And there is plenty of laydown space, harbor facilities that can be used for marshalling and loadout. So very quickly, operation and maintenance. Pelamis critically is a very big structure, and that is a big driver to how and where we site maintenance. And here's a couple of pictures to show. That's the Ham Nouveau leaving Stromness with one of the P2s behind it, and obviously the P2E, as you can see, is getting bigger. Operation and maintenance, the graph here on the left is showing some of the achievements that we've already achieved in terms of making interventions to retrieve the machines in EMEC. And that influences our ability to make maintenance interventions. But of course, development on components and reliability and things will also change the maintenance program as we go forward. And at the moment, we don't really run a conventional commercial maintenance. We're running an R&D project. But that allows us to build up lightly usage at a 10 megawatt array, number of times machines will be coming off site, kind of transiting distances and things. And then also, we have to appreciate that it's not going to be we can't expect 200 meter long structurally sound quaysides to be built every place we want to go and build a 10 megawatt array. So, and this is lessons we've already had to deal with, whether it's been in Portugal or at Lynas in Orkney. And in fact, we're kind of fine with that, and we've already adapted, and we took some of that learning and looked at infrastructure like temporary floating pontoons that takes us away from, generally good quaysides are good quaysides because they're used by lots of people. So they're not really conducive to turning up with 10, 200 meter long structures. So we need to be able to distance ourselves from these bits of infrastructure, yet stay local and not have huge costs. So we've looked at developing scenarios on pontoon facilities that would allow rafting of machines, boats in between. And we also built up a better picture in terms of what a staffing and some of the onshore infrastructure would be required. And perhaps less about the O&M, the machine supply, that's kind of building blocks in terms of if you want to do more, 20 machines a year, you probably just multiply that largely. O&M, we wouldn't see that quite as much. We would see more savings in terms of volume. So it wouldn't be a linear relationship as we grow. But these are so this is the outcomes of and some of the early findings that we've had in our supply chain study, and hopefully we will be able to publish more of those reports for people that are interested. And if you've got any questions, I will highlight I wasn't the person that did this study. One of my colleagues, Nick Pelosi, in the audience here, our senior production engineer, was the one that really did most of the work on this. And between myself and him, if you've got any questions at the end, hopefully we'll be able to answer you. Okay, thanks.